We've been talking on TDO about the difficulty of diagnosing vertical root fractures and distinguishing them from endodontic failures. So I thought I'd show this case. It's a first part of a three-part series. This case was sent to me by a TDOer. There was a sinus tract and a necrotic tooth, and the tooth was treated back in 2013. It wasn't filled until the sinus tract went away, and the case was packed out and everything seemed fine. 3 years later, however, at a recall examination, the patient came back and the sinus tract had reappeared, and the periapical breakdown had apparently happened, and the case was retreated, this time with calcium hydroxide, until the sinus tract went away, and then the case was completed after that. Fast forward to August of 2020, and the sinus tract reappeared. And at this point, we're starting to think about maybe there's a vertical root fracture and the tooth should come out. And it was, in fact, extracted, and the tooth was sent to me for analysis. So when we got the tooth, it was two separate roots in formalin. And when we took radiographs of the extracted roots, they looked to be exceptionally well done. You can see there is apparently some calcium hydroxide or something in the isthmus area between the mesiobuccal and mesiolingual roots. We also took a look at the distal root. And again, here it seems like there is a very wide isthmus area in the distal root. This is what the mesial root looked like. And you can see there's some black accretions on the root at the terminus. And this is actually the separate apical granuloma that was sent. We're going to image this in both with electron microscopy and with light microscopy. So the abscess was split into two and sent off for analysis. We're going to do several histological stains on this, trying to detect whether it's bacterial, fungal, or foreign body type reaction. And I'll be showing those in part 3 of this, along with the electron microscopy. So our procedure in doing this is we section the tooth horizontally in about 2 to 3 millimeter segments, and then we examine the horizontal section under the electron microscope. And then we take those sections and split them sagittally. So this is what one of the sections looked like. And because it looked to be very well obturated, we're going to focus only on the isthmus area and see if we can detect anything untoward in the isthmus area. These are the horizontal sections mounted on stubs before being sputter coated. And we're going to focus our attention mostly on the interconnectors between the two canals. So under the SEM, this is what it looks like, and we're able to focus on some of the axial wall simply by going up very high in magnification and examining the side of that. There you can kind of see the side of the isthmus area, and we're going to look very carefully. Then we take the root and we fracture it off and split it sagittally. We remove the pieces, and then we're able to examine actually the sagittal aspect of this and can actually look at the whole isthmus area along with the gutta percha and whatever else is there. And we'll look at that in part 2 of this series. For right now, we're going to focus on the axial view. However, this is what the axial view would look like, and part 3 will go over what those look like. So just to refresh your memory, this is the 2020 imaging where it was thought maybe there was a vertical fracture of this root. We could not detect a vertical fracture when we looked at the root. So here are the sections. We cut it up into 5 different sections, and we're going to look at each one of those. And I'll review a few of those sections with you in part 1 here. Here you can see we can examine the axial wall of where the split is. After it's been dried out by electron microscopy, it opens the root up a little bit. And when you actually go in at high magnification and look at the wall, you can see biofilm phenotype being expressed here, a lot of EPS, and what appears to be mostly fungal growth. It's hard to tell because there is so much EPS here, but it is a morphotype of fungi, perhaps Candida, and this looks to me to be a very well-established biofilm. When you look at the other side of the same section, you can see some resorption of the dentinal wall here, and when we actually go in and look at that with the scanning scope, you'll get a sense of what this actually represents. Now we're going to go into that area that looks like a little bit of a smear layer, and there could be a smear layer from just the sectioning procedure. But actually, when you go in and look carefully at what is going on there, again, you have a very extensive biofilm. Looks very fungal in nature when you look at it. And you see the typical budding of the yeast cells and the little vesicles that come off of them. This is the fourth section. Then we turned it over and looked at the opposite side as well. And you see pretty much the same thing. We'll go into that little finger area that looks like it's been eaten away or resorbed. And when you look closely at this, this is at the very tip of that finger. And when you look closely, it isn't any surprise what you see here is a lot of fungal and perhaps bacterial overgrowth. Again, you have to look at these at fairly high magnification to really be able to see what is going on there. And again, this looks very fungal in nature to me. And to me, it looks like a very mature, old, ancient biofilm. Here you can see these little vesicles coming off of the fungi. And it's known that these vesicles are the vesicles that actually supply the EPS that allows the fungi to bury themselves in this extra polymeric substance and be completely resistant to chemical or drug attacks against it. Then we're also going to look on the external root surface of what appear to be root gnar. And it shouldn't be any surprise what we find there too. Very extensive biofilm on the external root surface as well. This is the cut, the number 1 cut, and you can see that it looks to me like the canal has been very well filled here. And then we'll look at on the external surface of the root as well. This is the SEM of it. Now, we can go into one of the little areas where the canal there's a void, and then we'll go ahead and look at the root gnar and see what that consists of. So first, where the central canal is, we'll go in and look carefully at what is going on there. And again, you see a very extensive biofilm, probably fungal in nature, but also bacterial in nature as well. So this is a combined kind of infection. There you can see the bacterial morphotypes. Candida can also look like this, depending on what morphotype and what species it is, but this looks like a mixed infection to me. Now, when you go into the root gnar on the external surface of the root, again, it's no surprise. This is kind of a calcified biofilm The whole accretion is a, a calcified biofilm. And when you go into it, you can just see billions of organisms that are living on the external root surface. Now let's look at the distal root. And here it also looks like there's either an isthmus area or an extension of the distal canal. This is a photograph of what the end of the root looked like. It didn't look like there was much of an abscess there, at least compared to the mesial root, but there was some granulomatous tissue. That's the first slice of section 1. And when it's mounted on the stub, there you can see where the canal is very oval shaped. These are the different sections from that root. And it looks like it's pretty much at this level filled with a filling material or cement. But when you actually go into it and look carefully, you can see it's just impregnated with spores or yeast or fungi. And there's probably also bacteria there. The entire area is just filled with these morphotypes. You can actually see some budding going on. So we know that it is yeast, at least part of them are yeasts. This is the second section. This is how we sectioned the root and then split it. And this is section number 2, and you can see the area that hasn't been filled where the oval is. And we looked very carefully at what all that material could be. And again, it's just a very, very extensive biofilm. So looking at these with the electron microscope is very, very powerful. You get a different sense of what's really there. This is section number 3, and pretty much the same thing. As we go more coronal, the oval part of the unfilled canal becomes larger and larger. And then we actually go in and examine that black, glassy-like material. And of course, it's just a calcified biofilm with basically billions of organisms. This is further up, and you can see how extensive it is and how much material really is in that space. When you look at things like this, you wonder why any endodontic treatment even works. We're going to look at kind of along the axial wall there and right into that glassy looking material. And you can see it's a very ancient biofilm, mostly EPS, but there are organisms budding off from that area. So this has probably been there for years and years and years. So there's some very good review articles on Candida and some of the appearances of it and the phenotypic switching that goes on with fungal infections. It's very, very interesting. If you're interested, I recommend that you read some of this literature. It gives you a different perspective on what's going on. And a lot of people have done some very interesting electron microscopy work on fungi, showing that these polymers are mostly of the extracellular matrix, come from these little vesicles that the yeast spread out. And we saw many of those in this particular subject. So next time at section 2, we'll look at the sagittal sections of this.